This is Geometry B, Unit 5, Circles, Lesson 8, Radian Angle Measure. We're going to introduce a new way to measure angles. You've been dealing with Desmos so far, having to go click the wrench tool and choose degrees every time you open Desmos fresh when you use sine, cosine, and tangent. There is another way to measure angles, and that is radian measure. Radian measure basically is the measure of an angle. 1 radian is the angle formed by an arc length of 1 radius. Let me break it to you this way. There are 360 degrees in a full circle when we measure in degrees. There are 2 pi radians in a full circle because circumference is 2 pi times the radius. So it's how many radii fit around the circle. 2 pi radiuses, or radii, fit around the circle. So there are 2 pi. Now these are proportional, so let's go ahead and set up a proportion. If I want to convert from degrees to radians, I'm going to take new. Remember our scale factor? You take the new divided by the old. New divided by the old. The new measure is 2 pi radians. The old measure is 360 degrees. So the scale factor to convert from degrees to radians is 2 pi over 360. Well, let's reduce that. Let's divide top and bottom by 2. That gives me pi over 180. So pi over 180 is the scale factor to convert from degrees to radians. Likewise, if we wanted to go the other direction, let's say we wanted to go from radians to degrees, though you won't have to do that. Well, yeah, actually, yes, you will, because we'll be converting radians to degrees. No, actually, in this lesson you won't need to, but I do want to present it anyway. So going from radians to degrees, new divided by old is 360 divided by 2 pi. Reduce 180 divided by pi. So there are 180 divided by pi degrees in 1 radian. Okay? But remember the ratio 180, or another way to say it, 180 degrees equals pi radians. Radians are typically considered dimensionless. We don't write radians, but I'm going to write it just so it's clear what I'm talking about. 180 degrees is equal to pi radians. All right, now let's talk about how to use that. So remember the way we defined a radian is how many radiuses fit around a circle or fit within the arc length. So imagine, if you will, you take a string and you stretch it from the center of the circle to the edge of the circle. That's 1 radius. And now you bring it over and you stretch it around, curve it around the circle. That is 1 radian. 1 radian. If I take 2 radiuses and stretch it around, so 2 radiuses, 2 radii, and stretch it around, that's 2 radians. Okay? And I want to see if we can come up with a formula here. Notice that the arc length is 2 radians. The arc length is 1 radian. This gives me the formula S equals theta r, where theta is the angle in radians. Okay? And this is a really cool formula. If you need to know the arc length, the length of an arc that's subtended by a radius and an angle, in radians, all you need to do is multiply the angle in radians by the radius of the circle. Let me show you how that works. Okay, and actually I'm going to, now let me do this example first. Okay, there are some common radian measures that we need to be familiar with. You know that 360 degrees makes a full circle, right? So let me do this in yellow for degrees. So 0 degrees, 360 degrees. Okay, that's a full circle. If I go halfway around, half of 360 is 180 degrees. So that would be this angle right here, 180 degrees. We know a straight angle is 180 degrees. Half of that is 90 degrees. And 90 plus 90 is 180. 180 plus 90 is 270. Okay? And 270 plus 90 is 360. If we cut that in half, 90 divided by 2 is 45 degrees, perfect diagonal. 45 and 45 is 90. 90 and 45 is 135 degrees. And 135 plus 45 is 180. 180 plus 45 is 225. 225 plus 45 is 270. 270 plus 45 is 315. 315 plus 45 is 360. Okay? And then we can divide them into thirds here. Let's do that. So 90 divided by 3 is 30 degrees. 30 plus 30 is 60. 60 plus 30 is 90. 90 plus 30 is 120. 120 plus 30 is 150. 150 plus 30 is 180. 180 plus 30 is 210. 210 plus 30 is 250. 250 plus 30 is 270. 270 plus 30 is 300. 300 plus 30 is 330. And 330 plus 30 is 360. So those are some common angle measures that we deal with. Well, let's do the same thing, but this time in radians. Remember, a full circle is 2 pi. So halfway around is pi, because that's half of 2 pi. Half of pi is pi over 2, and radian measures are often given like this in terms of pi. Pi over 2. We have 1/2 pi, or 1 pi over 2, 2 pi over 2, 3 pi over 2. 4 pi over 2 is 2 pi. 45 degrees is pi over 2. Half of pi over 2 is pi over 4. 1 pi over 4, 2 pi over 4, 3 pi over 4. 4 pi over 4, 5 pi over 4. 6 pi over 4, 7 pi over 4. And 8 pi over 4 is 2 pi. And now let's do the thirds. Pi over 2 divided by 3 is pi over 6. 1 pi over 6, 2 pi over 6, reduces to pi over 3. 3 pi over 6 is pi over 2. 4 pi over 6 reduces to 2 pi over 3. 5 pi over 6, pi, 6 pi over 6, 7 pi over 6, 8 pi over 6 reduces to 4 pi over 3. 5 pi over 6, 9 pi over 6, is 3 pi over 2. 10 pi over 6 reduces, 10 pi over 6 reduces to 5 pi over 3. And let's see, let's do 6 pi over 6, 10 pi over 6, 11 pi over 6, there we go. And then 12 pi over 6 is 2 pi. So those are some common angle measures. Okay? So let's figure out how to find arc length here, given information. We're going to use the formula S equals R theta. So if you want the arc length, S, just multiply the angle in the radius by the angle in radians. So we have an angle in radians of 2 pi over 3, and we want to know the arc length if the circle's radius is 4. All you got to do is this, S equals R, 4, times theta, 2 pi over 3. Okay? Think of it as 4 over 1 and multiply. 4 times 2 is 8. So this is 8 pi over 3. That's the arc length. If you want a decimal approximation in inches or whatever the units are, bring up Desmos. Okay? And 8 pi divided by 3 is about 8.38. inches. This would be approximate, where 8 pi over 3 would be exact. Okay, but what about if we're given degrees? And that's another case here. So we're going to remember to convert from radians to degrees, and from radians to degrees we're going to multiply by the scale factor, 180 over pi, or pi over 180, pi over 180. To go from degrees to radians, pi over 180. So we've got an arc length we need. We're given an angle measure. So what we do is we do S equals r theta, where r is 4, and theta is in degrees, 150. But I need to convert that to radians, so I'm going to multiply by pi over 180. Pi over 180. Okay, the zeros knock off. 15 over 18 is 5 over 6. So this is 5 pi over 6 times 4. And 4 reduces with 6 to 2 over 3. 2 times 5 is 10. This is 10 pi over 3. Now, one thing to note that, well, 10 pi over 3, yeah, that's the arc length. And we can get an approximate value for 10 pi over 3. Let's do that here. 10 pi over 3 is 10.47. 10.47 inches. Okay, 10 pi over 3 would be exact. 10.47 would be not, would be approximate. All right, so that's how to find arc length. If you're given the angle in degrees, convert it to radians by multiplying by pi over 180. If you're given it in radians, just use S equals r theta.